thank you. I don't know what Gio said. I hope it was nice. My name is Thomas Andreasen. I come from Denmark, run my own one-man company, and apart from that, I'm also a Maxon lead instructor. I've been here on several occasions doing some classes, and I'm glad to be back. Thank you for inviting me back here. I'm going to be speaking mostly about, obviously, the new R20 release, and afterwards a bit of my own project. Hopefully you can get some tips and tricks that are usable. By the way, if I'm not speaking loud enough or clearly enough, just shout, wave, or something. I'll fix it. Cinema 4D R20 is a huge upgrade. You've probably heard that. Also, Maxon probably has tried to market earlier upgrades as huge, and they've been good, great. Many of the early upgrades have focused on speed and workflow, and adding, tweaking existing features to be even better than they were before. But this one, it's big. The OpenVDB modeling and the fields and the node-based material system are three very huge features. I hope to be able to do them justice, so you can have an idea of the power of these tools. But we'll see. Speaking of huge features, I'm going to start out with something that seems like a small thing, maybe a bit boring, but nevertheless a time saver in day-to-day work. Cinema R20 now has a CAD importer. If you've worked with CAD files before, you've probably been through a workflow of exporting the CAD files to something Cinema can read, or I did the workflow of I have Rhino installed, open the files in Rhino, saved as a 3DM file, and have a plugin for Cinema that can open 3DM files, or I can export an OBJ or FBX or whatever. Cinema can now open I think CATIA, SolidWorks, step files, IGES files, can't remember if there are more, but open them natively. And let's just get started with that and look at some of the features here. So, I have a step file here, and we just drag it in, and immediately we have these options that you might be familiar with from other importers from existing file formats that it can open. But here we have a series of settings. Choose original units, or we can force it to use the units we prefer. And there are options regarding what we want to import: geometry, splines, instances, helpers, hidden objects, etc. There are also some optional things about how it should treat the file upon import. Display, colors, layers. I'll give an example so you can see, and various settings down here as well. But let's just take this one file and open. It takes a little while. It's not the fastest Mac I have here, but the file comes in quite beautifully. And it's getting there. Yes. So we have this, which I don't really know what file it is, but it's downloaded from the internet, from I think GrabCAD. Originally a step file, and you can see over here in the object manager we have some geometry. We have this Fisher, and then we have instances. So Cinema 4D automatically creates instances from instances in the original file, and organizes it quite well. If you've used to work with CAD files, you'll probably know that sometimes you get 5,000, 10,000 objects in no particular order that you can use. I've had that on many occasions, at least. The workflow I used before worked quite well, but since I had my hands on R20, I haven't opened Rhino except for DWG files, which Cinema doesn't really handle as well as Rhino. I don't know why, but for step files, IGES files, this is a time saver. Let's check the geometry. It's quite all right, and as you can see, these black fissures can be switched on and off, and rendering is quite nice as well. But let's look at another file to better be able to quickly sort out these parameters. I'm going to go through this pretty fast because there are lots of other things we're going to be looking at. Okay, so I'll just open this with standard settings. And if I check the lines, you can see, oh my God. This is not good. So let's try to import it once again. Yes, we do want to open it again. And let's look at some of the options here. Display colors, layers, materials. As you can see in this file, there are no materials. We have something going on here with a couple of different colors, which is probably done by the layer colors in the original file. So let's set the materials here to be based on display colors. Okay, that's one thing. Then we have modifications here. What do we want to do with the mesh that we generate? Right now it's set to use original bodies, meaning it takes the original bodies, yeah, it makes sense, from the file and then just recreates them. We can also do by topology, color and layer. Let's just do it by color in this case. And on top of that, we have the tessellation. When you have a CAD file, a NURBS model, you have mathematically generated surfaces. But Cinema needs to tessellate these to break them into polygons upon import. We can do an original detailing here and a few other levels here, or we can do a scale-based tessellation. This means it subdivides the polygons dependent on their size. And let's just, now we've made the materials be based on display colors, we've combined the geometry by color, and we've added the tessellation, a scale-based tessellation. So let's import it once again, and let's see what we end up with. Okay, let's see. First of all, we have these three models, or three objects, based on the layer color. On top of that, we've also created a material for each of them, and the subdivision in the important places has been finer subdivided. So if we just copy this into the original file, move it over, you can see, it's difficult to see if I don't, there. So you can see, for instance, here, it's much finer than over here. And basically, you know, nothing's ever just black and white, but basically it just works in the instances I've tried. It's really a good implementation they've made. Yeah, so that's one of the boring ones, but probably one that if you use CAD files will save you quite a lot of time. And this, yeah, this is the first of the features. Pretty easy thing, just set some parameters and get working on it. Okay, the next one, multi instances. Let's, before I take the keynote, let's take 3D objects, plants, trees, something here. That's fine. Okay. And let's place this into a cloner. And I'm holding down Alt so the tree becomes a child of the cloner object here. Okay. And let's set this to grid 1, 5. I'm not going to do a lot of clones here because this is not the fastest machine out there. But let's see here. Right now, these trees are instances. As you can see in this instance mode. Regular instances, as we know from previous versions, we could also do, and if you see if it's not very smooth, really, if I try to navigate. I can do render instances, which is exactly like the old render instances, and then I can do the new ones, multi instances. And you know, the viewport speed is slightly better. It is better. It's not that much. But with these new instances, we have a way of showing them in the viewport in different ways. Right now it's set to object, so it shows the object. We can set it to bounding box. The matrix, it now just shows the matrices of the object itself, and points, which looks quite similar. So, and with these, you know, even if I set this up to be quite a bit more, obviously viewport navigation is pretty fast because we're only drawing these matrices or points. The render or the multi instances are also a bit easier on the RAM use, and the generation speed is far better than the regular instances. So, but if you just use multi instances, you wouldn't really, you know, experience much difference than the old instances, apart from the fact that they're faster, and your computer can handle many more instances in this way. So if I just close this one, the proof is in the numbers regarding this this feature. And if we just look at this keynote, let's get it open. All these images are from Mark Potocznik, render baron, who has created these. This next scene I'm showing here has 9 rig characters, copied 6 times to 6 groups, manually, or offset in timeline, 830 clones, and if we see here, 830 figures. This is done with regular instances, and the time has been offset with a random effector. The render time is 4 minutes and 53 seconds on this one. As you notice, there's a difference, because when we use render instances or multi-instances, we can't do the random offset in the or the time offset in the random effector. So these are without the time offset. Same number of figures and 20 seconds of render time. So that's quite a significant difference. The next one, quite a different set of numbers, 8.5 million polygons and almost 2 million objects distributed and restricted by polygon selections. And this is the animation. Mark has done a complete feature of this on SIGGRAPH, I know, and I think IBC as well, on how he created this scene. But this is the animation he did. And if we look at the numbers again, 8.5 million polygons, etc. Like I said before, opening in R19 took 140 seconds. In R20, it's 23 seconds. And step to next frame goes from 25 seconds to 4 seconds. Also quite a bit of difference. And render time, preparation time is greater in R19, almost 5 minutes, and R20 it's just over a minute. And the render time is slightly, or the raycast accelerator time is slightly longer in R20. I don't really know why, but it's slightly longer, but the end result is significantly faster. And the RAM footprint and file size, well, slightly less RAM, but same file size. Yes, that's it for the multi-instances. Just use it. If you can work with the limitation it has in regards to offsetting parameters in effectors and MoGraph cloners. So if you can use render instances, then just use multi-instances and save a lot of time. Yes. The next one is the motion tracker. I'm going to do this is going to be a bit of keynote, a bit of hands-on. These first ones are mostly keynote here. So I'm just going to open this one so we can get to the even more exciting features. The motion tracker has been improved. They've added some a few new features and made it a bit easier to use. And as they want to show, it's to focus on the user experience. What we basically do, I'm going to go through this and then just quickly doing a hands-on afterwards. We go to the motion tracker view, double click to create a motion tracker object, and double click to select footage. Then we open, and I think it is, yeah. Okay. Then we set manual tracking points. That's what I'm going to be showing you anyway. We're setting manual tracking points, and we can see them over at the right side in the motion tracker view, which has added new features. And as you can see here, these are the manual track points. We have various filters so we can sample different things in the footage. and we can group the tracking points and many more things. In the tracking view, the selected tracker is always centered, so we can get a better overview of what the tracker is doing and what it's fighting with. And we have a visual indication for the tracking, both the direction, which you can see on the arrows. We have the yellow keyframes as it is, and then there's a tracking direction. So from the yellow keyframe, we can see we've tracked backwards and then forwards. In the upper one, the second one is just from the first keyframe onwards, and it shows the green keyframes are good tracks. When it gets over towards red, it's worse tracks. It loses some of the precision. But there are remedies for this. Also, there's a pattern snapping. So if we have a tracking point, let it run, and then, as you see the track here, it disappears behind the tree. But then we can scrub in the timeline and take this tracker and move it over. Then it snaps to the tracking or the point once again, and we can continue tracking from there. So if we have something that gets out of frame and gets back in, we can take the exact same tracking point and then help it and create a better track this way. Then we have auto keying, so we can improve the tracking. If the tracker has problems and we get over towards the red tracking points, as you saw, keyframes as you saw before, we can help it and make it track better. I'm going to be showing you this as well. Okay, with virtual keyframes disabled, this is what is going through when it gets to a case like this, which is quite difficult for a tracker. So it can keep up with the rotation and then snaps to other places in the footage. With virtual keyframes enabled, we get this. Virtual keyframes are off on this one. You can see the first couple of tracks or frames are good, and then it gets red and they're no longer usable. Then we can set the virtual keyframes to a frame interval every 5 frames here. The blue ones are keyframed, and then it tries to track afterwards. Or we can set an error threshold. So whenever it gets too far away from the good track, it creates a keyframe by itself. And we have selection tools. Before it was lasso only, now we can use rectangle and the other selection tools, and common shortcuts, SH and the arrow keys as well. Masking as well has been improved. We can edit, mask, move them more efficiently. And this is a thing that's been done by Jonas Pils, one of the Maxon guys, both tracking this footage and reconstructing the tree, and then adding some magic with the use of fields, among other things. So pretty solid track here. Okay, but let's see how it works. Again, very fast. We first go to the motion tracker layout, double click. Now we create a motion tracker object, double click again, select the footage, and I'm just going to resample, set that to 50 to get a bit better overview. This is I've just been to Paris. This is just filmed with with an iPhone. It's a cut through Citroen from the 50s, I think. So, but let's see. If we want to create some tracks. We go down here, 2D tracking, manual tracking, and then right click on something. Let's take this spark plug here. Right click, create user track here, and let's see. Okay, and then we just set it to track forwards. This also, well, that was fast. So as you can see in the footage here, or the viewport here, it follows pretty well, and then it loses it. So follows it well and loses it, and then we get back around here. So now I move it, and come on, there it is. The tracking afterward is there again. So that's pretty easy. I can create a tracking point here, do the same thing. Now I started on, you know, quite a bit into the time frame. So instead of tracking in one direction, I want to track in both directions. I can use these icons up here, track in both directions, and backwards and forwards. So I track in both, and it's processing. Okay, and how does this work? That is also pretty fine, except here it loses it for some reason. And let's just click here. Oh, this one is the graph view. If I zoom in here, you can see these are my 2 tracks. And as you can see, here it gets unusable. You can see that by the color here. So if I click the virtual keyframes, it creates a set of new keyframes here, the blue ones, and the track is better. And let's just see how it goes. We can see it over here, and now it stays pretty solid. And we can do it on the second track point here as well. Enable virtual keyframes. Should be able to see this one gets, you know, a positive quality of tracking. Okay, and there are 3 different modes here, and you can see what works best for your case here. One thing we can also do is, as you can see here, the filter here is light green. The color filter is luminance, meaning the tracking point is looking at the luminance of the footage. If we have a footage that's, you know, a specific color or some other kind of issue, we might have better luck with one of the other things. The red channel, for instance. You can't really see what it is the tracker is seeing. It might work better, but if you click on this tracker view here, we can see this is what the tracker is looking at now. And you can enhance blue or whatever. So in this this way you can fine tune, and you can do that on each separate tracking point. So we're going fast here. So this is it for the tracker. But if you have any questions, just let me know. We have time afterwards as well for questions, but let's just
try to, like, what is the biggest, I don't know, synthesize the results?
I think it's 7 years ago I tried synthesize, so I can't really I can't compare them at all, unfortunately. But this I've had a bit of when the tracker first came out, the motion tracker. I've had a bit of difficulty getting the results I wanted, and I haven't been using this enough yet on production work, but it seems quite a lot better in my opinion. But I can't compare it to synthesize. So, okay, let's set it to startup. The next thing is the node-based materials. Have you worked with node-based materials, any of you? Yeah, some of you. It's a new feature for Cinema 4D. It's been in at least Octane has been creating a node-based material system and several other third-party renderers, but it's new for cinema. And it's also they've laid quite a bit of groundwork for how things are going to be created in the future, as you're going to be seeing. We still have the regular materials, the shaders, the new materials, like we always had, new PBR material that we've had for a couple of generations. Now we have the Uber material, more of that later, and node material presets. But let's just create a new node material. Now when we double click this, we get quite a different layout than we're used to. And this is, it's a bit resemblant of the Espresso view, if you've worked with that, but it's been enhanced, and I think this is something that's we're going to be seeing more in future versions, I believe. We have a series of icons up here, functions, buttons. I can get into that as well. We have the nodes listed here. We have assets. I'm going to explain these. We have assets here. We have some information. Here we have the node graph view. We can see all the nodes here, connect them. And we have previews over here and parameters. Okay. These node-based materials work in kind of the same way that the PBR material works. So we're working with the reflectance channel to create the materials. So we don't have, as we did in the old materials, the color and diffuse and specular reflectance or whatever. We have a BSDF layer that can be either a diffuse or a reflective material, and we can add those up with several layers. So there's going to be new things to learn. It's not as simple as the old material system, but that still works. So that's perfectly all right to use that. The node-based materials are powerful, really powerful, but also a bit more complex to set up initially. So, but that's often the downside of power and possibilities. Okay, so let's just get into it. Right now we have a material. This is the end result. This is the end material that we end up with and can use on objects. Right now we have a BSDF layer and we have a diffuse node connected to this. This diffuse node, as you can see when I select this, I can adjust the color, and this is connected over to the result over here. That's fine. It's also here we could add an image. So let's just take an image and go into materials. Whoops. A texture, image texture is what I'm going to be using. This one. Just drag it in. Okay. So now I can connect this to the color on this node. So this inputs into the diffuse node. And as you can see, this updates, and the result from here is sent over to the final material. Okay, that's okay. But what if I wanted to have some bump here? Well, I can use the same image here if I wanted to. But as you see, the material here doesn't have a bump slot like we used to with the old one. We have a normal here. And I can try to connect this. It doesn't give the expected result because this is not what we're supposed to do. So I need to have a bump node and connect this texture to the bump node and into the normal node. So for this I need the assets. If you're familiar with Espresso, you have a pool of Espresso nodes, and here you have a pool of nodes for the materials. There are about 150 of them. And it's difficult, you can't remember everything and know everything, but at least we know it has something to do with bump. So let's, if I click here, I get a search string here. So I search bump. Oh, there's a bump map. That's one way to do it. I can also just press C. Do any of you use the Shift C in Cinema 4D to find different tools? It's great time saver. In here you just press C because sorry. I don't. Place the cursor anyway here, press C, and I get the search field here. So bump, oh, there it is. I drag it in. Excellent. So now I can connect this one to this one. And this is connected to the normal. But then, usually, bump maps are made with grayscale images. And yeah? Yes. Yes, let's check them now. Yeah. We have various colors here. The yellow ones are meaning they output or need RGB. The gray ones here wants grayscale values. You can add them, but they interpret everything as grayscale values anyway, so they expect grayscale. And the purple ones wants vectors, so directions in some way. And then there are the blue ones. Can't remember. Sorry. But at least the others I can. The green ones are kind of final material outputs. And we have two things here. We have this bump map. I think I'll just turn this one off. No, I'll just do this. Turn this one off. Okay. So it's a bit clearer to see. It's not that obvious, but now we can really see the effect of the bump. Is it clear for everyone? Yeah, hope so. And in this node, I can, adjust the strength as you're used to. But I might want to have more control of this, and I want to make this a grayscale. So I can add a color correction node or a gradient. Let's take a color correction, press C, color correction, that's here. And I can drag that into, if I drag it onto the connection here, it automatically connects. So now I have a color correction. And what do we do with that? Well, first of all, I'd like the saturation to go down to a grayscale, or and I can play with, as you can see in the preview over here, I can see I can play with the lightness of this, which affects the bump map node here, and in turn affects the node over here. But we can also say, well, we have this. We want to, I'm just keeping it the blue just for now. We also want some reflection on this. And like I mentioned with the reflectance in the PBR materials, we have this layer here, and we can add several more layers on top of this. So if we go here, we can click add, but the efficient way is to go here, click add a surface, BSDF, and then it just adds another diffuse node. Well, that's not really what we want, but this, as you can see here, the BSDF type is set to diffuse. We have Beckman, GGX, Fong, Ward, and anisotropic. Let's just set this to a Beckman, which is, as you can see here, just really reflective material. This is the node over here, and this is the final result. Right now, this node here is cancelling out the layer underneath, but we can do two things. We have the nodes here, or the connections here, so we can adjust the opacity here, or we can go into this one and go down here to the Fresnel effect and say, what is this? It's a conductor, which is all kinds of metals, or dielectric, which is everything else. And let's set this to dielectric, and now we have various presets for this. We also have that with the conductors, a lot of different presets. So this is, working with physical workflow, so it's maybe a bit more complex than we're used to with the old material system, but it's the right way to create predictable, more photorealistic results. So now we have this, and we are dealing with a wood surface, and we might not want the reflectance to be uniform, because you have scratches and worn places, so you need the surface to have some variety. And let's press C again. Come on, where is it? And why is this not working? I just go over here then. Let's take a gradient, just a basic gradient here. I'm going to pipe in this image into the position node, and as you can see, this is the result right now. What it's doing is it's taking it's kind of like the colorizer, if you're familiar with that, taking the input and mapping it to a black to white gradient. So if I move these, come on, there. Oh. You can see I can, create a different map for this. or I could take this and make it a bit brighter. And then I'll pipe this into the color, so we now have the color of the reflection is adjusted over here. Let's just drag this onto here and let's see what it gives. Well, that's difficult to see. Let's just disable the normal here. I'll just take this one off. Well, I'm sorry, it's still difficult to see. And still? Oh, crap. Let's see if we can get something. Let's see if this. Come on. Yeah, I'm fumbling about here, but hopefully it gets. I'm using the physical render, so I'm dealing with a bit of a semi slow machine, so I don't have the samples that high, but now you can. Come on. Let's see if I'm. Oh, it's difficult to see. There is something. You'll have to trust me, or else I'll spend too much time on this. There is a bit of variety here on this part in the reflective bit here, but that's not. Let's see. Let's pipe this in again. The thing that is the important part right now. I'll pipe this into here. As you can see, it can get complex pretty fast. It's simple nodes that you just connect, but when you create materials, it can get a bit complex looking pretty fast. But one of the powers of the node-based systems is that right now we have one texture map. And that's piped into both the specular or reflectance and the bump map. We could pipe it into different parameters or parts of the material, and it's all controlled by just one map. This one is going to go down, and this means that we can change the entire material by just exchanging this one map. This automatically. Oh, I might have taken a wrong one. So now we have a new map, and that's changed all the bump and specular or reflectance parameters as well. So that's pretty efficient. Previously we had to go into the color with the map, the diffuse perhaps, the bump, the reflectance, and so on. Now we can do it in a very efficient workflow once things are set up. But you can also do something else, because if we have this and say, well, this is fine, I've done all I want with this material. I may need to, or I need to exchange the wood material, but all these things I've set up here is quite okay. So now I've selected these. I can right click and group nodes. So now it's created a group here. Everything's still there, but it's been cleaned up, and we only have this one to focus on. So this makes it easier to see. or to get an overview, I can, by clicking on this one, I can go into the group and see what I want to, if I want to add something or change something. And I also have this field over here. If we go back here and I click this one, you can see over here and in the attribute manager, I'm just going to close this one. Oh, sorry, next step. In here I have this one, but let's open this up. I can also say, well, for instance, I'd like the strength of the bump map dragged over here. Add input. Okay, and I might need, well, let's see, the intensity of the this layer. I want here, add input. So this one is bump strength and the other's intensity. Okay, that's fine. So now when I click this, I get these parameters here. So I can, even though the material is closed, I can still access these directly. But if I double click this one, I still get this picture up. I might say I'm a technical director, or I'm the guy in the company doing the materials, and the other people are just going to exchange whatever is necessary and adjust the texture and some strength or something. Then I can go up here. We have these icons here. This is set as start node. So if I press this, we get a different colored outline. It's green now. And now when I click this, I only get these inputs visible. If I double click, I get this. It looks more like the old system, but I only have these inputs that I've decided are the right ones. You can still go to the node editor, go into this one and work on with it, but this is a way of cleaning it up. So this is some of the powers of the material, or the new node-based materials. And you know, as you can see, with so many different nodes, there are really a lot of options to explore. One thing, if this looks like, you know, it's too much, but we still want to use the node-based material system, Maxon has created a Uber material. Well, this is a node-based material, but they've gone ahead and recreated an interface that kind of resembles the old material system. So this simplifies things quite a bit if you like to work with the older system better. So we get something that looks kind of like we had before and can work with it in the same way. But it is node-based, and we can, you know, harness the power of the nodes if we need to. Just for kicks, you can see this is what they've done. Yeah. So things can get pretty complex, but it also shows how, you know, how much you can clean it up if you want to. You can also, from the node, you can create an asset for sending out to other people, or for you know, like before we had these shaders. Now you can create a node assets you can send to clients, or you can sell, or you can do whatever, and they're yours, and you know, in the same way as I've done here, basically. Yes, but time is running. So I am getting on with it. How much time? Yeah, time is running. Okay. fields. The in my opinion, single best feature of this upgrade. And if they only added fields, then that would be quite alright, because it is huge. But what are fields? Well, in pre R20 we had fall-offs for effectors and various things. Fields now replace all of these fall-offs. And what's the big deal? Well, quite a bit actually, because we can do so much with these new fields. And if we just take a simple example, let's go to this create a matrix object, create plane effector. Well, what it does is it moves all the matrices 100 centimeters up in the y direction. Okay. And the plane effector looks as it's done for quite a while, except here in the fall-offs tab. Now we have fields. We have basically, we have three different menus here. The first one is for field objects. Then we have filters or special layers, and then we have modifier layers. Let's just start with the fields here. So these are field objects. If I add a spherical field here, what this does is it restricts the effect of this plane effector to the area within the object here. Okay, but we have this list with the fields. These two buttons here controls the parameters, X, Y, Z, scale, rotation, etc. And these are colorizers or colors. And in some cases we also have a direction. Very few cases, but there's also a direction here. So I can switch them on and off. So right now the spherical field only affects the color of the clones matrices here. If I switch that off, switch this one on, it affects the parameters, which is set up here. But, well, this is all fine, but, well, let's just take a random field. Where's this? That's here. Okay, what does this do? We have the objects, the field objects here in the objects manager, and we also have them here in the list. They don't need to be a child of the effector here. They're just there because I created them this way, but they don't need to. They can be anywhere in the scene. And as you notice, this one only affects the parameters here, but if I switch this one off, it also affects the colors. We also have an opacity here, and we have blending modes. And this works pretty much as in Photoshop. You stack the layers and you adjust the opacity in the blending modes, you can really do some awesome stuff with this. So let's say, well, this is the minimum. Let's just hide this one because it's not very. So what it does is, as you can see here, needs to grab this one. And I'm just going to create the max here so you can see the difference. So it uses the minimum or maximum values and then only applies them if they're over or under, depending on what you set it here. So now it's only using the values from the random field that are larger than the ones from the spherical field. It may sound complex, but it's really not. You can overlay it, so you get the same effect as overlaying in Photoshop. Black and white doesn't get, this works like black from black to white, where black doesn't have an effect, white is full effect, and now you have in the grayscale values or the middle values, you have some sort of effect here. Does this make sense or seem logical? Excellent. And again, you can also do it with the colors here. But what you can also do is, we have these objects, or we have various other objects here, but we also have these modifiers. And let's set a delay effector, delay field, sorry, or effect on this. If you know the delay effector from MoGraph work, this is kind of the same. Let's set this to spring and then turn it quite a bit up. Nothing really happens, but let's see when I move these. So now, just as in the MoGraph stuff, this works on the effect that is generated by the other fields here, and we can also do it with make it affect the color. Or just the color. Well, I think you get the idea, hopefully. And these, as I mentioned, these don't have to be inside the plane object. They can also be attached to other effectors. And I have, I'll just run through a few of these fields here. So here we have a normal field. This is this field over here. Does a bit of what I shown before or previously. We have a plane effector, and this plane effector has a random field. And the random field, I'm just going to, come on, let's get the transform, has a noise with an animation speed. So this just goes up and down. The other file, or the other model over here, basically has the same. See, this is the same. But now we've added a filter which quantizes. This means it makes steps, like posterize in Photoshop. Take a grayscale image and posterize it into values. So now it posterizes the movement of these clones here. And on top of that, we put a colorizer. So we have, let's turn this one off so it's easier to see. So the colorizer colorizes these clones from blue to green. And not to spend too much time, this one's not that important. This one is a spherical field that is shared by two effectors. One of the effectors is a formula, which, if we press play, scales these clones. The other one is a random, but they're using the same field. So two different effectors share the same spherical field here. But let's see. Let's get rid of this. Let's see. We can do many more things with this. Then I'll run out of time. I think I'll just take this one. I'll do a bit of groundwork before we get to this one. This is completely controlled by fields. There are no keyframes, and it took about 15 minutes to set up this entire effect. And this is something, you know, at least I would think would be fitting for Houdini work or something, and spending quite a bit of time on that. But it's, you know, it's kind of easy to do this. If we just look at a simple example, we go to a plane, subdivide it, 50, 50, press C. So now we can see we have quite a few points here. Then we want to add a vertex map, because fields work with vertex map and selections as well. So now we add a, where is it? Tools. Vertex. Come on. There. There it is. Set vertex. Wait. Exactly. So now we have a vertex map. And in here we have use fields. So if I click this one, we instantly get a freeze layer, which really does nothing right now. It just, you know, saves the state of the vertex map here. And if we press play, nothing happens. Well, that's all fine. Let's add a field. Let's see, spherical field. So now we can see this field now adjust the vertex maps. Have you worked with vertex maps before? They're quite powerful for many cases, and they just got a heck of a lot easier to work with. So if we set this here, let's go in here and say, okay, we have the spherical field, we have the freeze layer, and the freeze layer has this max, mean, average, and grow mode. Let's see what happens. So what happens now is, we need to get back to start. It takes the vertex, or the vertex color here, and then grows from that point. This doesn't look nice. Let's see, because we need to do something else. Let's add a, where is it? Random field. Okay, and let's overlay this. Let's add, you know, random noise. Let's say 600 something. Or let's multiply it. So now we get this effect. It grows by itself, and it gives a bit more organic look to it. We can also add, well, let's say for instance a where is it? The decay, for instance. So now it grows minimum, right? Max. Oh, come on. That's not working as I wanted. Doesn't matter. We'll take the file and look at this, because because the thing and C and Q, okay, and D. And let's check this one off. Okay, what's happening here when we press play is that these spheres are falling, hitting the name here, and inside here we have, to be able to use dynamics for this, I've put the spheres here in a fracture object, added a dynamic tag, and set this model here as a collider. And in the vertex map here, I've added this fracture object. So now this fracture object, and let's get outside. Let's see here, outside here. If I go back, press play. Let's turn this one off as well. So now you can see the vertex maps are being painted with the spheres when they hit. But on top of that, I've added the freeze as we had before and set it to grow. So now the vertex map grows whenever it gets hit by, whenever it gets a starting value, that is. I need to reset it. So now it grows. And on top of this, a random field. So it gets a bit more of an organic look. And then I've added the delay, not the decay that I just did before, but I've added the delay, set it to spring. And what this does is that if you look at the color of the, so you get this ring effect. Because the values go up, they go from red to yellow and a bit back again, and then up to yellow again. And well, this is just a vertex map, so we need to use it for something. First of all, I've used it in a displacer, because a displacer can now also take its displacement from a vertex map. So I go into Effects, Vertex Map, in here, and drag this one in here. So now the displacer displaces according to the vertex map, which is also kind of what I used for the shading part of it. Because what happens is that it goes from, again, slow machine, but let's just get it started. It goes from the white, shiny kind of material into the black, bumpy material with a glowing halo just around the edge of it. And I'll just let it get to the other side so we can see it a bit better. And I'm finished shortly, at least with the R20 stuff. So let's just, come on. I just wanted to make you see the edge here. Yeah, that's it. And the thing that's been done here is we have two materials. One's a regular material, and then we have the black material. And the black material is, well, it's black, it has a bump, a Voronoi fracture, that's fine. And then I used the vertex map inside of the alpha channel. So now we have the same vertex map that's being generated by the fields and the animation I use here. And I've remapped it, so that's a bit of trial and error. Remapped it like this. And then I've colorized. Oh, sorry. I've colorized the vertex map. The vertex map is a grayscale. It goes from black to white when it goes into the texture here, and then I've, like I did before with the node-based, I did the color correction or gradient. It's the same thing I've done here. I've just adjusted it so I get the edge where I wanted it. And basically the same thing is done with the colorizer. You can just see a bit of a different effect because I wanted to have the red glowing color at the edges. So that's a bit of trial and error. So this is how this has been done. And then a bit of After Effects work, which a bit of extra glow and so on. But the good thing about this is that we can adjust the animation of the spheres or throw something else inside there or anything, and it runs by itself. We don't need to do anything apart from make it play. And yeah, so, and this is, as you saw before, this is the final result. Okay. The last really big thing for R20, OpenVDB. Well, this is a big feature as well. It's placed inside these range of objects here. We have the volume measure and the volume builder. We can create, modify, and mesh volumes. We can't, in usual OpenVDB, if you know something about that from Houdini or whatever, it's usually used for rendering. You can get clouds or smoke and stuff, and so you can use Octane, for instance, and other renderers to render OpenVDB files. This is not available yet, so I guess it will be in coming versions, but it's not yet. But we can use it for modeling, and the OpenVDB can use all kinds of objects from cinema. So as you see here, there's a spline, a sphere, and a cube. We can use hairs, we can use other things. Something like this I don't know how this should be modeled easily or efficiently, but it's really created by a big sphere and a torus for a handle, some hairs. This is one volume, and then the torus's outside here has been used to cut off the remaining geometry. It's layer-based modifications. You add them to a list. I'm going to be showing that. And rendering isn't possible as a volume renderer, but it's a modeling tool that we can render. This one, a cheese. Add spheres, add a volume builder, add the spheres, subtract the spheres, and we have this with rounded edges and with it's fully animatable. It's it's quite good. And I have something like this here. It's not the same, but this is just what it's made of. And we have a volume builder, and all the elements are thrown in here, and the spheres are made to subtract from the shape. We get this volume and this. I thought this was easy to create, and maybe I do something else that's also easy, but it shows the workflow. If we were to model a kettlebell, for instance, that's not difficult, especially difficult to model as in a regular way, but let's do it with the OpenVDBs. So this one. We're about halfway there now. Okay, let's take the volume builder and throw these two inside of here. So now we get this volume, and the voxels or volumes here are basically 3D pixels, kind of like in Photoshop, or a kind of point cloud, or what you can call it. So they're basically 3D pixels, and we have a voxel size set to 10 centimeters. This is the resolution of the cloud here, or the pixels. As you can see now, this is faceted. I'm just going to go down here, so we get a finer mesh here, or a finer volume. Some of the primitives here have this options to click perfect primitive. So this looks a bit better. Now we have these two. I like, you see we have an okay blending here. I like a smoother blending. So we also have these smooth and reshape layers. So if I press the smooth layer, now this is smoothed out. This currently isn't rendering because it's just a volume and we can render volumes. So we need to put this into a volume measure. I hold down Alt to make it a child, and now we can render. But if we were to make something else, let's see this one here. This looks kind of okay. Let's put this one into the volume as well. Now you can see this. This is now a part of the volume, and you can animate all you want. But I want to, instead of this set to union, I want to intersect. So now I get this quite easily. And if I wanted to have a, let's see, MoGraph, Mo text, 12 kilos. It's not much, but it is something. Set it to middle here. Let's say I want to animate this in some way getting in. So I don't want that to be a part of the volume builder hierarchy over here. So I can just take this one and drag it in. And now you can see out here we have children and we have a link. So this one is linked to the volume builder without being an object itself. This also means that it shows now and it renders. We don't want that. So I'll just do this. And then I want to subtract it. So we have this indentation. So this is quite easy to work with. It's also a bit of a dense mesh we get from this. There are options to fine-tune this and to to add some adaptive sampling. But we do get quite dense meshes in standard settings. But this would take a bit longer to model, or you can build some rather crazy stuff quite easily with this. If we just go on with the here, something like this. This one, I have this file as well. It's built out of primitives. So weird stuff is, well, that's easy, but it can also be used for more practical purposes. And you can throw most things at it. Just drop it into the hierarchy or link it, add, subtract, or intersect. This was created by one of the Maxon guys. Just took some Mixamo rigs and added some spheres, and then put it into this volume builder. We can have noises. We can, create 3D representations of noises. And I don't know this. Oh, yeah. So lots of crazy stuff and practical stuff. We don't have time to go through these bottles, but they're in the content browser. So please take a look at the content browser and see some of the examples there, because they're there and they're pretty easy to set up. It seems, by the guy who did it, a guy called Jan G, which he's insanely good. These things. Imagine modeling this with either hypernerves or subdivision surfaces or bools and making it soft like this. Animated noises. And one more thing that's really powerful about these OpenVDBs is they're very, very usable for 3D printing. Because you can throw everything at it, create the model you want, and then export it as a model. It's a solid model that 3D printing wants, and you have rounded edges and so on. So it's really a good tool for that as well. And these are just examples of. And this one by Yang Ge, again, a Chinese guy. Yeah. This one, I promised to, or I said I'd show this one. Come on.
One question.
Yeah.
It's possible to use mesh plus procedural object, or you need to use only procedural objects?
Both. And you can use splines and hair and even fields as well. So yeah, this is if we turn off these, it's just a bunch of objects. But with the other, with these settings, we can control the fillet and the shape of it. Okay. Yeah, I think I better get on with the last part of it. That's for last. ProRender has some additions as well. I'm not going to be showing them because my computer can't take it. We have out-of-core textures and motion blur and subsurface scattering and multipasses, which has been missing. So it's getting more towards the production-ready renderer by now. And Octane, Redshift, the other are still ahead of it, but this is built in. It comes free with Cinema, so it's available for use, and it's a bit of a different workflow to work with GPU renderers like ProRender. And a few additions as well with the physical sky, MoGraph color shader, separate ray depth on various parameters in the render settings. Multi-instances work obviously, and we can use shadow catcher and 2D noises. So quite a few good improvements to that as well, making it more usable for production work. These are a couple of the examples. These scenes are also in the content browser of R20, so you can open them and examine them and test them out for yourself. And this one as well. And there's more in R20 apart from these things. The new gradient, new interface, new functions, color choosers updated, Alembic features, new console, new modeling core that you won't really see, but it's there, it's under the hood as preparation for things to come, and they improve stuff, speed and so on in some cases. But they're laying the groundwork for things to come in the future, and the modeling core is one of them that's already been done. The assets in the content browser has around 150 new assets and many more changes and additions. Some things that are cleaned up is coffee is no longer supported, and there are a few other things that are no longer supported because it's been cleaned up. This also has an effect on third-party plugins because they have to recompile, they have to rewrite some of their plugins to make them work. This takes a little while, but it's all being done to prepare it for the future and create a better and more modern program core for future work. So this is this is what I had for the R20, and my time is up. So as it is now, there's no part of my own projects that I was going to be showing as well. But these features, I think they're awesome, worth spending the time on. One thing I really need to show. So if you have the MSA, the Maximum Service Agreement, you get free access to Cineversity, all the content there. One thing really worth noticing, because I know well over 1,000 video tutorials there. So that's one benefit of having an MSA. I used it for some of my projects because there are things I don't know a bit about, and that's just wanted to inform about that if you didn't know. So this is it for me now, if I'm supposed to keep my time, and I am. So thank you for your time, and yeah, thank you. And of course I'm available for questions afterwards, or whatever, just shout or whatever. Yeah.
Yes, thank you Thomas. Meillä on nyt tauko. Ottakaa sieltä jotain syömistä ja juomista ja jatketaan tauon jälkeen.
Thank you. Is it something I have custom? Thank you. Yeah. Yes. Thank you.